This video will cover section 5.3, part 2. We are going to start on problem number 6. So what I'm going to do is select pi times x as u. So that would be u equals pi times x. And if I take the derivative of u with respect to x, it will be pi. Or we could use the other form, du equals pi times dx. And why is it pi? Because pi is the coefficient of x here. And so if we use power rule, it will just be 1 times pi. And then we'll subtract 1 to the exponent. So that, yeah, are we okay with that part? Why is it just pi? Okay, so then if you guys look at the problem, what we need is somehow 1 over x, and we also need dx. So from what we have here, none of those, pi is not going to be what we need. We only need dx. So what I'm going to do is solve for dx. So that's going to be dx is equal to du divided by pi. Why is it divided? Because pi is multiplying dx. So if we take it to the left side, we'll do the inverse operation. So what we're going to do here, before I do the u substitution, I'm going to break this integral into 2 integrals, into the addition of 2 integrals. So it's going to be the integral of 1 over x dx. Well, actually, let's not do that. Yeah. Oh yes, we're going to do it. So, and then the integral of secant squared of pi times x dx. Okay, so the integral of the first one, the first integral, that one is one of the formulas. So that will be, actually, once I solve it, I don't need the integral symbol anymore. So that's going to be natural log of the absolute value of x. And then it will be that, if you're thinking about the constant c, that we'll have it at the end, plus the second integral, the integral of secant squared of pi of x dx. So now the u substitution is going to be used here. Okay, what we're going to do now is use the u substitution here. So that will be the integral of the secant square of u. And the part that has the dx here, we still need to make up for that somehow, right here. And so what are we going to substitute dx with?
1 over pi times du.
So let's write it first like we have it here, for those of you who were not here on Thursday. So it will be du over pi. Now, the reason you guys are hearing 1 over pi is because we can do that, and it will be equivalent. So here, this is not going to change. It's going to remain the same, the ln of x, the absolute value of x, plus. And then here, we could say that 1 over pi times du is equivalent, right? So what we do is we're going to take this pi, 1 over pi, factor it out of the integral, so it will be here. And then we're going to have the integral of the secant square of u du. So pi is already here. Okay? It's still there. Now, one of the formulas that you have, where are my notes? Oh, here. One of the formulas that you have that was on your quiz was that the integral of secant square is going to be tangent of the same angle. Or if you think in terms of, yeah, let's just leave it like that. So natural log of x plus 1 over pi, that one is just tangent of u plus c. And then the last thing that is left for us to do is to back substitute the expression that we chose for u, which is just pi over x. Not pi over x, pi times x. Okay. And that is the final answer.
Can it be tangent x?
Tangent x. No.
The one over pi and then, or no.
No, this one is the coefficient of the angle.
Okay.
And the 1 over pi is just the coefficient of tangent. So no, we cannot cancel them. Okay, now let's go to example 7. And what we're going to do here is we're going to choose u to be sine of x. So we're going to let u equal sine of x. So if we take the derivative of u, du over dx is going to be cosine x, right? The derivative of sine x is cosine x. If you look at the function, we have here cosine x times dx. So that's why I chose u to be sine x and not sine square x or anything else. Okay, now how can we get to this part right here? Well, by taking dx to this side, right? So dx is dividing on the left. So it's going to be multiplying on the right side. So we'll have cosine x times dx, which is what we need to substitute here. All right. Now, since we said u is equal to sine x, and here we have sine square x, then what should we change that with? U squared. Very good. So u squared instead of sine square x. And now instead of cosine x dx, what do we substitute that with?
Du.
Du. And then this becomes one of the easiest integrals, right? So you're going to add 1 to the exponent here. So it will be u cubed over the same as the exponent, 3, plus c. And now from here, we do the back substitution so that we can get the answer in the correct terms in terms of x. So that will be, we said that u was sine of x. So u cubed is going to be sine cubed of x over 3 plus c. So yeah, I should have started with that one. That one was easier. Okay, I'm going to go over the first one briefly. Okay, so we divided the integral into 2 because we had a plus in between. Then this was an easy integral to calculate because there's a formula attached to it. So this was natural log of the absolute value of x. Now for the other integral, that's what we needed, the u substitution right here. Then if we do that, we make that equal to u. We have to take the derivative of u with respect to x, so that was pi. And then for notation purposes, we needed to have dx alone. And so we used the same, but it took us 2 steps to isolate dx, and so that's what we used in our substitution, which is here. And then here, instead of pi x, we substitute it with u. Then we factor out the 1 over pi, that you can see here. And then by the formula, the integral of secant square of u is tangent of u, which you see here, plus c. And then after that, we did the back substitution, where we changed u into pi times x. Yeah, that's it. Okay, so let's go to the next one. You guys have a question? No? Okay. Okay, now the next one. Are you guys ready? Yes?
Yeah.
All right. So what do you guys think we should make u equal? Well, let's look at it. What is one thing that repeats in both numerator and denominator? The square root of x. Not e. And if you think about it, the integral of e to the x is very easy, right? What would that be? E to the x plus c. Right? So instead of making that u, let's use the square root of x. So u will be square root of x, which you all know is x to the 1/2, right? So to take the derivative of u with respect to x, it will be 1/2 by using power rule times x, 1/2 subtract 1 to the exponent. We're deriving. Negative 1/2. Okay. Now from here, I'm going to make it look like a square root again. So it's going to be 1 over 2x to the power positive 1/2. And if I put it inside a radical, it will be like 1 over 2 the square root of x. Okay, so what I need is du dx equals 1 over 2 square root of x on the bottom. Yeah, are we okay with that part? Okay, I just took the first one and then the last one. All right. Now from there, let's look at the problem, and I'm going to rewrite the integral still in terms of x. So it will be integral of e to the power square root of x times 1 over the square root of x, and then times dx. Right? Isn't it true? It's equivalent. So you notice we're very close of getting the quantity here. Now, we're very close. We're almost there, except that this 2 is just messing us up here. Right? And also, we need dx on the right side. Okay, so we just need to manipulate the variables a little bit. So I'm going to take the dx to this side. So instead of dividing, it will be multiplying. So it will be here. And here I have du. Now the 2 that used to be here is dividing. So if I take it across, it's going to be doing what? Multiplying du. So now instead of dividing here on the right side, it will be multiplying on the left side. Why did I do that? Because that's what I need to substitute. This part right here, you guys see, that's what I need here. Okay. I know it's not easy, but I'm doing my best to do it slow, and I actually went over the clock. And you guys are free to watch the video over the weekend, you know, if you're bored. Okay. Whatever. Okay, so now we're ready to do substitution. So we're calling the square root of x to be u. So instead of having here e to the power square root of x, I'm just going to say e to the power, what letter? Okay. Now all this stuff here is going to come from here. Because this expression and this one are equivalent. Okay? So then 2 times du. Yeah? Are you guys maybe? Is it starting to click? Okay. Okay, then what can I do with this constant here? Take it to the front. Okay. We'll take it to the front, so let's factor it out. Now we have e to the power u du, and you all know that the integral of this part is going to be what? E to the power u, That's it. Plus c plus c. And now we'll go back here and we take the square root of x. So we back substitute u. Okay. And the more examples you guys see, the more you will understand. Okay. That's why I made the handouts, so you wouldn't have to copy the question. Yes.
When you need to pick that what you want, you can like choose whatever, right?
Yes, but it's kind of like a skill. Like, remember when I taught you guys trigonometric identities and it was so difficult? But now maybe you're able to recognize them more. It's what happens here. The more you do, the more you will get the skills to recognize what will be you and what not.
But if you like pick e to the power square root x, it's a different answer.
Well, you will get this for sure. But you wouldn't know that there's a 2 on it. And the reason for that is because we also have this stuff. Okay, let's move on to 9. And here 9, it was a little difficult at first because I thought that this said t to the power 43. Did I see that?
Isn't it t to the power 4 and then a cube root?
Correct. So it's actually what Karina says. T to the power 4, and then there's a cube root here. Yeah. It's weird. Okay. Once I figured that out, the problem wasn't so difficult. Okay, so I'm going to give you guys a little bit of time to think. What is the hardest part? Don't say anything. Just think about it. What is the hardest part to understand or to integrate from this question? Don't say anything. All right. I'm going to throw this forward. Yeah, that was all yours. All right, Samantha, what's the hardest part? What do you think? It doesn't have to be correct.
You mean like the hardest part?
Yeah, but what would you make you?
I think figuring out what you is.
Okay.
Because that's
I agree with you. I agree with you. All right, let's think about it. If you just had the integral of t to the 4th, would it be easy?
Yes.
Yes. If you just had the integral of the square root of x, would it be easy? So what's messing you up? What's inside the square root, isn't it? The cube.
Wait, is it a cube root or?
I'm sorry, cube root. Cube roots are easy to integrate as well, because you can follow the same x to the n plus 1 over n plus 1. So it's what's inside the cube root. That's the hard part. So that's going to be u. Most of the time, u is going to be decided that way. Sometimes you have to think more. And I mean, if you guys are going to be engineers, I can assure you that you will need to develop this skill, integrating. Especially if you're going to be a civil engineer. I don't want to die. in case you construct the bridge wrong.
We'll see.
Okay, so we're gonna make u be 3 minus 5t to the 5th. Now you guys find the u over. Oh,
Can you do it 5/3?
what do you mean? Clever?
Yeah, can't you
Because
just
it's like
undo
Can you
the
just
cube
undo the
root?
cube root and do like 3 minus 5t to the 5/3?
Yeah, can't you just do that?
What?
No, right? Because it's a 3.
Like undo the cube root.
How?
So,
Why?
Because remember you're telling us like if there's an exponent inside the cube root and then it's like a cube root, you just put it
5/3. Like it's t5/3.
Okay, I get you. If we just had one term, yes, we could. Like if we have that, yes, we could just say, we could even say 5 to the power t, 5 and then 1/3 here. We could say that.
You could do 5/3.
But the problem is that is a difference. So you have more than one term, so you have two terms. So that's why we cannot just do that. So yes, we go back to u. I know you don't like it, but you guys have to get used to it. So du.
Can you like multiply t to the power 4 times dt? Then it's gonna be like dt to the power 5. And then you have t.
Wait. Why would it be dt to the power 5?
Because you multiply.
Like t to the power 4 times dt. Okay. This one goes together. So not because it has a t, because this one is a rate.
Oh,
This one is the variable t, and this is the rate of t. The rate. So I know it looks tempting, but no. Plus, we need to have dt somehow. Okay, so you guys notice what would happen if I put dx? That's it. It's wrong. You don't even know what's going on.
Supposed to be
dt. Okay, so what is du over dt? You derive here.
I got 3t minus
5
25.
times 5
25.
t, and then remember, because when you start integrating and deriving, Patrick, when you start deriving and integrating, then sometimes you might make a mistake like, do I add or subtract the exponent? So you need to be very conscious of what you do. So here we're deriving, says t to the power 4. Okay. Now you guys starting to recognize there's certain things we need from here. We need dt. And what else do we need from the right side?
T to the power 4.
T to the power 4. Exactly. So we just need to manipulate those right here. T to the 4 dt. Okay, so now you guys try to do that. It's here. It's u. So what I'm going to have is the integral of the cubic root of u. And then this part here, what is it going to be?
Oh,
So
1 over negative 25 du.
negative 25. Right now, this negative 25 dividing is like having negative 1 over 25, isn't it? Right? So that is the constant that we're going to factor out of the integral. So we'll have negative over 1 over 25, and then the integral of this here. So instead of writing the cubic root of u, we're just going to say u to what power? A fraction? 1/3, and then du. So if we integrate that by following the x to the n plus 1, right? We add 1 to the exponent. So what is 1/3 plus 1? 4/3. And then we divide. We divide by 4/3. It looks like a 41. Okay, and we have that plus c. Now, what we have here, what will be the denominator? We'll have a fraction over a fraction, so what's the denominator of u?
1.
1. So if we have u to the power 4/3 over 1, and then we divide by 4/3. Do you guys remember how in pre-cal we used to use the sandwich rule, right? So we multiply those two, we'll get 3u to the power 4/3. And then 1 times 4 is 4. Or you can think of this, if you're dividing by a fraction, isn't it the same to multiply by the reciprocal, right? Yeah, does it make sense? Okay, so here the answer will be -1/25 times 3/4 of u to the 4/3 plus c. And of course, if we multiply here this fraction, first and second fractions will have -3 over plus 25 times 4, 100. Okay, u to the power 4/3 plus c. Maybe if you find yourselves at night not being able to sleep, you can watch my video. Maybe that will help. So if we go back and do the back substitution for u, it will be -3 over 100. And then what we substituted for u at the beginning, top left, right below the problem, that was 3 minus 5t to the power 5, and then we have this 4/3 will still be out here, plus c. And Alan, if you know how to integrate this type of functions, when you take your class, you're going to be very good at it. Yeah, oh, these are like, wait. Okay. What time do we have? Oh, I have 4 minutes. I can do one more. Seriously. Okay, let's do it. Okay. So before we start deciding what u will be, I'm just going to write it a little different. And see if you start recognizing some of the integration formulas. Square root of 1 minus e to the power 2x times e to the power x dx. Yeah, are you guys okay with that rearrangement? All I did was to move this one, right? And then I put a 1 over the fraction. Okay. Now, what is the difficult part there? Well, it's not e to the x, right? 1 minus e to the x. Yes. But we're actually going to use u as our easy part. And the reason for that is that the derivative of the easy part happens to be the same as the easy part. I'm sorry, not the derivative, the integral.
Oh, so it's e to the x.
Perfect. So we're going to say u is e to the x. So then du dx will be e to the x because the derivative is the same. But we need e to the x times dx, so I'm just going to take this dx across. So it will be du equals e to the x times dx. So sometimes you choose u to be the easy straight. Well, think about the following. If I tell you, oh, you choose u to be 1 minus e to the power 2x, will that be an easy derivative or a more complicated derivative? Okay, what I mean is not like an easy to find, but like a more elaborated derivative. So that's where you have to think of that too. Is it going to get me in more trouble if I take the derivative of that? And yeah, it will be more elaborate. So, okay, so we go back to this one. And what we're going to use, then you're going to recognize it if you study for the quiz. 1 over the square root of 1 minus. And now if I am saying that e to the x equals u, what would u squared be? Focus right here.
E2x.
E2x. So if you're not sure, ex, when you square it, what do you do with the exponents here? Multiply. Oh, Jonathan, do you remember when you used to ask me where we're going to use that in real
What do
life?
you mean me?
That was quite wrong.
Yeah.
If you're listening. So e to the 2x. So right here. I'm sorry, instead of e to the 2x, what do I need? U squared. And then this part right here is here, so what do I need? U. All right. Now, if you study for your quiz, you should know what that is. Let me check how much. Sign in. You were close. You were close. Sine inverse of u plus c. And that will be sine inverse. Back substitution, what do we say u was? E to the x. That's it. Now, yes? Yeah, you guys are figuring out.